that was that was types of the types of networks where we learned about some um, where we learn about WAN, LAN, then Ethernet lens, rings, FDDIs. Okay, so we learned so that FDDI is used for fiber distributed data interconnection, where we learn that this is this is the outer ring and the next inner is the inner ring. Okay, both of is of fiber optics. So when we are working with a long distance, and it may happen that the ring may get break up due to any reason. Someone starts digging, even though it may happen that the ring may cut. So both works in anti-clockwise. Clockwise means one is a clockwise, other is in uh, either position, that is anti-clockwise. So both ring, if single ring goes down, other ring, or we can say it is a redundant ring, starts working along with. So it becomes very easy for all. It becomes very easy for all, and for all hosts to have connection at any time. So all these hosts which are in a connection, network connection, will have can share the data without having any issues. Okay, it becomes very easy. Like next is that we have gone through the speed, each and every, if it is an ISDN, it has a specific speed. If it is uh, ISDN, then T1, Ethernet, token ring, fast Ethernet, FDDI, gigabit Ethernet. Okay, everyone has its own speed of connection. So it becomes very easy for all what network requires what type of identification. So whenever we are in interconnection network, we know what type of devices that we use, what type of connection we can have for proper transmission of our data from one source to destination, as well destination to source when the data comes back. Okay, so using the interconnection, we have the technologies like to make an interconnection, we have bridges, we have routers, we have a bridge router, both as presently we are having, and the gateways, and the connection type is of LAN WAN. You know, yes, hello, okay, it is audible, na? Okay, so let us go with the next is, so see, when we are using bridge is used to connect two devices that links to similar LAN based on protocol. Okay, so when a protocol is used, so so protocol is used, it is in same LAN. So we can use bridge. Okay, and bridge and route hub are known as similar identification of the devices. So both can be used in inter LAN over the same premises. We can share the data for our convenience, and becomes very easy because bridges are bit uh, cost effective, means having less cost than routers, because routers are used to connect two different networks. Okay, if we are using a computer networks of an LDRP, okay, so LDRP also takes connection from some other ISP. So ISP has a different kind of connections, different networks. Okay, so an ISP also connects or also receives the services from different number of other big ISPs from where the networks are being shared. So the routers can connect to or more different number of networks as well. So So the computer that connects different types of networks using a different protocols, they uses routers. Presently, what do we have? We have a different number of switches, many number of routers and switches that works similarly. So the bit costly switch if we purchase, so it also works like routers, bridges, firewalls, and and kind of gateway also. So it becomes very easy for or you know premises holder or a lab holder or the network holder that by using single switch we can have a work of many different devices like bridge, router, hub. Okay, so it becomes very easy. So the single device that combines both the functions of bridge is we can also club it along with the routers, hubs, then firewalls as well. Because presently the switches are of programmable switches. These programmable switches can program in such a way that that it can have the control of all the users, all the IP addresses, and others as well. Next is gateway, the network device that connects two different systems, that is networks using direct and systematic translation between the protocols. Now this is a high level of device that connects two different networks. Okay, so as we talk about the LDRP, now the LDRP has its own network, but it doesn't goes out of the network. So what happens over here? The data roams around the LDRP like intranet. But if we make use of internet, what do we have? We need to have a gateway by what the users can but the users can use the internet services using the gateway. So many different number of packets are starts traveling out of the campus using a gateway using single core connection to the ISP. Now ISP starts accepting different number of number of packets through through a gateway and combines at the ISP and that is gateway of other networks and makes the translation of each and every packet and converts them into different number of more number of packets using some protocols. So the protocol translation will be there from a single LDRP network to the ISP network. Now what happens next? So this is a scenario what we have. So here what we have, like if we have a branch in New York, then Canada, other part of Canada, and we are sharing all the networks. So here it becomes very easy. One is using router, other is using gateway, other is using bridge, other router, and as well more number of routers. So bridge to bridge or router to router connection they made, and they clubs at the ATM, that is asynchronous transfer mode. Then all the frames becomes combined. Okay, all the frame becomes combined, and the data using a gateway it is being shared to different number of ISP. So it becomes very easy and even for all number of hosts to transmit the data to receive the data using single gateway. Okay. Now very important is if so that it may happen that you have a question that what happens if more number of data, more number of hosts, more number of networks are connected over a single LAN or a single protocol. How the system is going to share the data. Okay, how the data can be uploaded or can be downloaded over the system and can be given to each and every specific user from where it is being generated, specific host from where it is being generated. So very simple is at each and every stage of your host. That is when you are sending a Google.com request from your system, it fetches a different number of protocols, and it starts giving to next device. Like if the host is there, host gives it to the routers or a switch, router or switch, whenever it receives the data from a host, what it does, it gives its own header and footer, leaving behind the actual header and footer of your host. So router next to your host will have a virtual memory where the information of your request is generated, and once it has been generated, what happens, the router keeps the record of each and every host request. Okay, one is using uh, google.com, other is requesting for yahoo.com, other is requesting for flipkart.com. The router has a capacity to create a table virtual table in what sense, making the connection very foolproof that nobody, so whenever the data receives in any form, whenever a data is received from any in any form, what it does, it makes the use of virtual table to make the data send to and fro. And then when it moves from router to ATM again does the same. Whenever it does a same activity, frame relay, that is at the ATM, it has a huge virtual memory where it saves the router's request, and these number of packets received from the router to ATM again sends and again attaches some header and footer to it, and again the header and footer will new header and footer will be attached at the ATM. So ATM, what it does, it relays to the next gateway or next level of the ATM, where the next ATM, it does the same activity, removing the destination, source and destination of last host, and attaches its own till it is been forwarded to the source, that is the server. And when it comes back to your, when the reply comes, the same reverse activity does. ATM removes the high level of ATM and attaches the actual one. It comes to router, what it does, it fetches the data of a user from virtual table, and virtual table, what it does, it has an actual user information of particular length. So the data are being pulled to the actual user, and user will have its own the request of google.com, maybe yahoo.com, or maybe the flipkart.com. So each and every data which are being transferring from source to destination and coming back to destination to source may go changing it source and destination addresses. Okay, but when it comes in the similar form from where it been generated. So it is, it is the beauty of network through by which the same route is being used. Okay, next, so it is been done the protocol, using the protocol. Now before we go with the protocols, we have seen the network diagram. Okay, we have seen the network diagram. So the network diagram, the whatever it happens, source and destination, blah blah, it is done using the protocols, because the protocol defines the rule that governs the communication between both computer to the network and networks to computer, because both are connected through a single channel. And what is the role of protocol? It is the role of a protocol for addressing each and every packet, addressing, routing of a message, error detection, recovery of an error,
Okay, sequencing of very important is sequence, that is sequencing of each and every packet whatever it makes. Okay, whatever number of packets are being generated in whatever the sequence, it is being arranged in sequential manner because as number of packets are moving and each and every packet has its own sequence because on the basis of sequence the flow can be controlled as well. Okay, so to control a flow, because your system may has a lesser configuration than a router. Okay, so when a lesser configuration device communicates with higher device which has a good configuration, both will not match the flow control of each other. So what happens? The router inspects the user and user host and says that this is your configuration. Okay, so the user sends 5 packets every second, as well a router sends 50 packets, for example, 50 packets for each second. Okay, so the ratio may differ, but the flow control of receiving of a packet at a router side will be managed using the host using protocols at the host side. In the same way, the router sends 50 packets per second, but the ATM or a gateway may accept thousands of packets each and every second. So 50 packets is nothing in front of 1,000 packets. So the flow will be controlled between both the devices using this protocol. Now, whenever the protocol comes, it becomes very, yes, yes, okay. If you have any question, you can also make a chat. You can also, stop me at any moment of time. Okay, Badana, everyone's the okay. So next is, so it becomes the duty of the protocol to make a specification consist of a syntax. Okay, now what is syntax, as you know? Okay, each and every protocol follows a syntax. If a packet comes with a similar syntax, that is similar packet after encoding, okay, it is being extracted at the device and it will be used for sending the further. Okay, so the format must be unchanged. Okay, and the formats of a message exchanged between two different number of devices. So what happens, which defines that defines the kinds and the formats of message are unchanged, and the semantics which specifies that the action taken by each entity when when specific events occur. Okay, આમાં બે વસ્તુ two thing happens. Number one is if a packet is not with respect to the syntax. So if it is not proper in the form of syntax, it may be identified that someone has tempered the data, tempered the message. So it becomes very easy for a protocol to identify that this is tempered message or having a loss of a message and not having a proper packet. Okay, so it sniffs and puts away for identification or the retransmission because the ongoing event should not be disturbed. So the specific event, whatever it is being used, it is been starts working very easily and seamlessly. Okay. Now, as the protocols are designed based on layered architecture such as OSI reference model. Okay, you know the specifics of OSI models. Okay, why it has been designed. Okay, Why it is been designed? It is used to identify the number of hosts as well. Number of hosts and its working. Okay, whatever the layer they are using in OSI layer, okay, each and every layer has its own importance. Though the thing is, OSI layer is never been implemented. Okay, but it simplifies the activity of each and every layer of the host and its activity, those the packets which are moving from source to destination. And on the basis of OSI layer, we have identified that TCP layer, when we combine two or more layers, the TCP is very easy to implement over the network. So we combined some protocols and made a TCP or TCP IP architecture for the next implementation of protocols into the devices. But to identify the activity, OSI reference model is very, very helpful. That is why OSI model is always known as reference model. So by taking reference, TCP/IP model has been developed. So each entity at a layer n communicates. This is we are talking about OSI layer. Okay, layer n communicates only with entity at layer n minus one. N minus one એટલે નીચેથી as we know the working of OSI layer. It starts from physical to application layer. But when a user starts activity, it the data flows from the application presentation, then session, transport layer, the network layer, data link layer, and the physical layer. Then it moves to the network. Okay, so as it works from application to physical, it it is very easy to understand the activity from physical to application layer. So we can have it as well. So the activity is only be identified entities that supports layer n minus 1. Okay, so the each and the data exchange in a OSI layer, data exchange known as the protocol data unit goes back and forth through the layers. Means the data which are moving from upper layer to lower layer, it is known as back and forth through the layer. It moves from around the protocols and adds and removes its own header and vice versa. Therefore, the layer n protocol data unit may become a layer n minus 1 data. So it goes to the network as the arrow shows. Now the arrow identifies it, and then the arrows, that is the number of packets that comes over the network that identifies it, and then it goes to the next host. So vice versa can be done. So TCP/IP makes even connection for all. Okay. Now the OSI layer. Let us not go the deep discussion of OSI layer, because already you have gone through the computer networks, then CNS also. Okay, and other subjects maybe. Has the OSI open system interconnection data model is the standard for computer networks design and functioning, involves at least 7 layers, each playing a specific role. When applications are connection over the network. During the sending process, each layer from the top to bottom will add a specific header to a raw data, and at the reception, headers are eliminated conversely until the data arrives to the receiving application. Okay. This is the layer architecture of OSI. Application, presentation, session, transport layer, network layer, data link layer, and physical layer. let us go from the physical layer, that is that defines the physical architecture of a network. Okay, that means the device to device communication થાય છે કે નહીં એ આપણને ખબર પડે. So it identifies the physical connection between all the layers. Okay, the devices to devices. If it is connected through a hub, LAN, switch, router, everywhere the ARP packet is being sent and received on the basis of the communication. That is why when you are using an Ethernet port, that link or green light is blinking for identifying that communication is there between two devices. Next is data link layer. It is very very important because it provides a safe communication. Okay, the duty of data link layer is very important. It makes the communication stable because of flow control. It makes the error control. It makes the error correction. Okay, different number of methods are there, as you are aware, hemming code, then columnar and others. Okay, then it makes the scanning of each and every packet. Okay, and again it gives a unique identification of a system or a host for sending a data to other hosts. Next is network layer. It deals with all the network devices. Those are and those handles the connection to the network by higher layers. Okay. Next is higher layer, that is transport layer. It worries only about end-to-end transmission, detection, and the correction. If any packet comes with the packet which is not proper or snips which is not proper, it is being discarded or the retransmission occurs. So the acknowledgement that comes from the transport layer, it is very very important. Okay, for end-to-end transmission. Next is session layer. Okay, it manages the session amongst the different number of applications. Okay, so the number of applications that we have, it has its own specific time for refreshing and the communication. Like ATM or the online banking is there, we know, or online transaction is known. We know that it has a specific time of session. If session expires, we need to relog in or regenerate the system. Again, the presentation layer. The presentation layer makes the even breaking of our packets, makes the even connection of the data. Okay, and makes passes to the session layer for the next. And the very top is application layer. Now the application layer means that communicates between any other, it communicates with all type of the applications that we are working. Okay, so if we are using WhatsApp, browsing of any data, it becomes very even communication and seamless. Okay, so this was about the OSI layer. The next, okay, this is the description what we have gone through. It contains the application which uses the blah 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 you might be knowing. Okay, so on the basis of OSI reference model, we have generated a TCP/IP model. Okay, so TCP/IP model. So as TCP/IP model is very important, in the same fashion, OSI reference model is important. In the same fashion, it is very important to know about the TCP/IP model.